everyone, and welcome back once again. This is your senior first otter speaking, and in this episode today we are going to go over the pneumatic system of the Airbus A320. In the background we are going to be taking off out of Fort Lauderdale before making a right turn straight down Miami Beach, low level, nice and fast, and getting some beautiful views of the city of Miami Beach, and the Florida Keys, continuing straight down State Highway 1 before landing in Key West Airport. So, jumping straight into the pneumatic system for the Airbus A320. This system supplies high pressure air that the aircraft uses for air conditioning, starting the engines, anti-icing, pressurizing the water tanks and the hydraulic tanks, as well as heating the cargo if your aircraft has that fitted, and a fuel tank inerting system. We can get high pressure air from three sources. One is either of the engine bleed systems, one is the APU compressor, and the last one is a high pressure ground connection, which is incredibly loud, which you use to start the engines with in the event of a APU inop. So, there's a cross-bleed duct that connects all of these inputs and distributes them to the relevant systems that need them. And there's a valve mounted in that duct so that you can isolate either side of it in the event of any issues. In flight, the aircraft will take the high pressure air from the engines, and each engine has an air bleed system. Each system is designed to select the compressor stage to use as a source of this air and regulate its temperature and pressure. A bleed monitoring computer will control and monitor this system, and in the event that one of these computers fails, the other can take over, although at a reduced capacity. These computers also supply the ECAM and the CFDS in the event of something going awry. The air bleed selection is normally taken from the intermediate pressure stage of the engine's high pressure compressor, so pretty high pressure. But at low engine RPM, that's just not enough, so we're going to take it from the high pressure stage. We have an intermediate pressure check valve downstream of the intermediate pressure, so if you think about it, we're taking high pressure air. We don't want it to flow into the intermediate section, or we're going to start messing up the engine. So this valve stops that happening. Then this air comes out of the junction of the high pressure and intermediate pressure ducting, and it goes through the bleed valve. This bleed valve acts as a shut-off and pressure regulating valve, and it maintains pressure there at about 45 psi. So bleed pressure can actually fluctuate between 38 and about 56 psi, so don't look for exactly 45. And this depends on engine power, what altitude you're at, and those sorts of things. Really, it's like any other indication where you're looking for it to start pulsing green or go amber before you think there's a problem. So, the bleed valve. It can be fully closed. It can do this either pneumatically if there's an upstream pressure, which would be very strange, and we don't want pressure going through the bleed valve the wrong way, and that will go obviously above 8 psi, or if there's a return flow. It's also done electrically if we push the bleed push button switch on the overhead panel, the engine fire push button, or if the bleed air monitoring computer detects an over temperature, over pressure, some leak, maybe the starter valve is stuck open, if the engine shutdowns automatically, APU bleed being selected to on, or if there's no need for any bleed, or finally if the bleed temperature is lost. If pressure regulation fails as well, the overpressure valve is going to close when the pressure goes above 80 psi. And this is all just to protect obviously all of the other systems. So cool. After that we have a pre-cooler downstream of the bleed valve, and that regulates the temperature of the bleed air. Because we don't want things too hot now. The pre-cooler is an air-to-air heat exchanger. It uses air from a NACA duct, ram air from outside the aircraft, to then cool that air down further to a desirable temperature of about 200 degrees centigrade. A temperature that I'm sure you and I can both agree would be very nice to enjoy an ice-cold pina colada in. A spring will keep the fan air valve closed in the event that there's no pressure. So, pneumatic air is also available in flight and on the ground via the APU load compressor. The APU bleed valve is operated as a shut-off valve to control the APU bleed air, and it can be controlled via the APU bleed push-button switch on the overhead panel. This controls the APU valve and will deliver air when the APU is spinny-whinnying up above 95%. This will open the cross bleed valve as well and close the engine bleeds automatically. So, if the APU bleed valve is opened, it can be automatically closed if there is an APU leak, a left wing leak, or pylon 1, and the check valve is located near the cross bleed duct. What this will do is it will shut in the event that bleed air starts getting bled towards the APU. Which is a situation we don't want, obviously, backwash and all that. So, the crossbleed valve itself is located on the crossbleed duct, and that allows air to supply the systems of both engines from the other. But it also allows it to be isolated in the event that maybe there are contaminants and we don't want to risk damaging something more than it already is, or breathing in horrible, horrible gases. It's controlled by 2 electric motors. One is for the automatic mode and one is for the manual mode. Manual is literally, it goes to the position you select using the rotary switch on the overhead panel. Automatic mode, the cross bleed valve will open when the system uses APU bleed air, and it will close if the system detects an air leak. Now, public safety announcement at this point. We are dealing with a lot of hot air. And when air is hot, it can cause fires, and we don't want that. So, we use a leak detection system to make sure things don't get out of hand. For the pylon and the APU, these sensing elements are tied to form a single loop, and in the wing there is a double loop. The logic is that if both of these loops detect a leak, then a signal is generated. The only time one will set one off is if the other loop is deemed inoperative. These will send signals to BMC 1 and 2, and they contain identical control logic for this. In the event of a wing or pylon leak, the bleed valve on the related side will close automatically. A fault light will come on the overhead panel. The cross bleed valve will close automatically unless there's an engine start happening. And the APU bleed valve will also close automatically if the leak is on the left, or for those more nautically gifted, the port hand side of the aircraft. In the event that an APU leak signal is generated, the APU bleed valve is closed automatically. A fault light comes on the overhead panel in the APU bleed push button switch, and the cross bleed valve will close automatically unless there's an engine start. So let's talk about what happens if a BMC fails. Now, on the whole, this isn't that much of an issue unless we have a problem on that side of the aircraft. The other BMC will monitor the overpressure, overtemperature and wind leak signals that the failed computer was monitoring. However, we will now have lost the fault light on the air conditioning panel on the overhead, as well as the associated bleed valve will not close automatically if we have a problem. So, as you can see, in terms of diagnosing a problem and the ramifications if we have one, it's just something to bear in mind. In terms of the overhead panel, it's a fairly simple affair. We've got the cross bleed rotary switch, as well as the bleed selection switches that we have already roughly talked about. The ECAM bleed page is, however, a little more interesting. As you can see here, it tells you whether or not anti-ice is being drawn from the system, which systems are supplying it, and where in the engine they're getting the air bleed from. The key points really that we're looking for if there is a problem are going to be the pressure and temperatures. as we said, you're looking around 200 degrees, around 45 psi that you're expecting to see in those boxes. So, you eager beavers, thank you very much for joining me. I hope you enjoyed this video and that you found it useful. If you can think of a way that I can improve it, do let me know and I'll try and incorporate that. And in the next video we are expecting to go over the air conditioning and pressurization system.